Okay, let's talk about triangles today. We're in lesson 4.3, but I have a question for you first. And it's, what is the minimum I need to know to make a congruent triangle? So maybe I have like some secret triangle over here, and I need you to guess what it is or draw exactly what it is. What would I need to tell you, right? Well, if I give you one side length, right, you could draw that side length, right? And then I'd say, well, draw the rest of the triangle. Well, maybe you would draw like this, or maybe you would draw like this, or maybe you draw like this. Like the chances that you would actually draw the same triangle with me are pretty low, right? So let's try another one. So if we had one length or one side, that would not be enough. Okay, so let's say we had two sides, right? A side and a side. Okay, so maybe I give you one length is this, and I give you this other length here, right? Well, does it go here? Does it go here? All of these lengths, I can make a triangle out of. I can put one here, I can put one here, right? Where these are the same length, right? So that's not enough either, right? Now, what if I gave you a side, but then I gave you an angle, okay? Well, I could give you this angle right here. And I could say, okay, draw a length maybe of 5, fine, and draw an angle of 40, what is that, 92, and you draw an angle of 92, and then you put the length of the other side on there, right here. Now you can tell that this looks really close to that. Now, if I connected those, I'm actually going to end up with the same length as this length. So if I give you a side and an angle and a side, I get a congruent triangle. Now, just checking, what if I gave you a side, and an angle? I'm not going to do about that because we don't talk about bad words in math class. This is a bad word, so we don't do that one. There's another reason we don't do that one either, and we're going to get to that later. Okay, so but if you have a side, angle, side, I could do that. Now there are other ones. What if I gave you 3 sides? Well, you'd have side 1, and you'd have side 2, right? And then you'd have a third side, right? And maybe these 3 are the same. You know, and you can make them as sticks or something, and then you'd put them together, and there's really only one way you could put it together. Now, you might put it together backwards, so it was like this, and then 1, 1, 2, 3. But I could still say that this 1, 2, 3 was congruent to this 1, 2, 3 by a reflection, so it's still okay. All right, and so before we do our theorems, which are basically what I just showed you, I want you to understand how to label triangles and how corresponding parts is very, very important. So if I have triangle ABC and I want to say it's congruent to DEF, I would need to say A is congruent to D. So I'd say triangle ABC is congruent to, and this is important especially because this one's reflected. So if A goes to D, then I need to put the D first. B goes to E, so I need to put the E first. And then if C goes to F, I need to put the F next. So that these lines, so now when I look at these two triangles, I'm like, angle A is congruent to angle D, B is congruent to angle E, and C is congruent to angle F. And on top of that, I could say AB is congruent to DE, BC is congruent to EF, and over here, AC is congruent to DF. So I can get all my corresponding parts put together. All right, that was your whole lecture in about 1 minute. So now I'm going to slow down and do it with the book and write the theorems out, okay? So here we go. Follow along in your book on page 167. So theorem 4.3 is side, angle, side, congruence criterion. And what that means is criterion is just the criteria that you need to know that they're congruent, and it's side, angle, side. And probably I'll never write side, angle, side again. I'm just going to write SAS, and so does everybody else in the world who's ever taken geometry. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So if this is congruent to this. Well, I guess if this, then A, B, C, D, E, F. I have two triangles, then you could just, oh, you can't read that, I'm sorry. If triangle A, B, C, D, E, F look like this, and they have two sides that are congruent, and through angles in between that are congruent, then triangle A, B, C is congruent to triangle D, E, F. Now do not write EFD, because that's not right. That's not right. The EFD, because A does not correspond with E. Just, I know I keep saying that, but it's a pet peeve of mine for you to write the triangles with not corresponding parts. Next, let's come over here. All right, theorem 4.4. Corresponding parts of congruent triangles are congruent. And that just means if you have two congruent triangles, guess what? Every single corresponding part better be congruent. So if I say triangle ABC is congruent to triangle DEF, then it better be the case that angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F, AB is congruent to DE, we have lines here, BC is congruent to EF, and AC is congruent to DF. A, B, C, D, E, F. Now you are going to use this theorem a lot, because what you're going to do is you're going to prove two triangles are congruent, and then you need to show that two sides of those are congruent so you can prove something else, right? So this theorem 3.4, I would not remember the 4.4 part, because in every single book, this numbering system is different. But you do need to remember this whole line. Corresponding parts of congruent triangles are congruent. Now, you may not write CPCTC like the book says. You have to write this. This is the minimum. Corresponding parts of congruent triangles are congruent. You may write that, oops, right here to represent this theorem. And that is the absolute minimum I will accept, okay? Because CPCTC, blah, 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 you're gonna forget what that means. And I need you to basically write this over and over again, okay? One more, and you're done. Okay, side, triangle, sorry, congruence criterion. I'm reading backwards on my screen. It's a reflection. So if I have three sides of triangle ABC are congruent to, oops, these are not congruent to each other themselves, they're congruent over here. If I have three sides are congruent, then triangle ABC is congruent to triangle DEF. And this is abbreviated as side, side, side. Okay? So if you're using this theorem in a proof, you would say by SSS, and that's okay. And you'll get used to doing that too. All right, so try some of these problems on your own. Mostly you're going to be trying to use these theorems to prove other things. It should be okay. Bye-bye.